That's how we name or label a line, different than any other line. And there's two forms, usually. There is something called a general form. And then there's y is equal to mx plus c form. The general form is when it's all equal to 0. So an example of the general form is 2x plus 3y minus 7 is equal to 0. This is all brought over to one side. An example of it in this form, which is probably a way more useful form, is where we many examples. Why is that other form more useful? Anyone tell me why this is more useful than that? Jill?
I don't know.
No? No one tell me why this form is more useful than this one? Gabe? You can identify the gradient and the y-intercept, yes. So that's the key thing about this form. M will be the gradient or slope. And this C number is always the y-intercept. Always. So we can read straight from this one. 3 is the slope of this line, and it's uphill. Positive slope of 3, and it will cross the y-axis at 7. That will also help us draw that line. So drawing lines have two methods. First method, use the gradient and the y-intercept. That might require a rearranging. Look at a quick example of that in a second. What was the second method yesterday? Or it was actually I called it the first method. No, I didn't. All that. It was the X-intercept and the Y-intercept. Use both methods. So this one is generally used when we're given an equation in this form. So y is equal to minus x plus 2. I'll just do a very quick sketch of that over here. I have enough information to draw a sketch already. When it's in this form, it's easy to read the gradient as minus 1 here, because there's no number in front of x, but it would be multiplied by 1. And the y-intercept is 2, so we start with the y-intercept at 2, and then we use the gradient. So for every one box over it goes, this one goes down 1, because it's a negative slope. So one box over, one box down, that'll be the next point, and so on. And I've already joined those together with my ruler. That is the line y is equal to negative x plus 2. That's what we did yesterday. That's pretty straightforward, if it's in this particular form. We usually use the x-intercept, y-intercept when we're given it in general form, kind of not in this form. So let's look at an example of that. Well, let's just draw, let's make them whole numbers. Okay, so this is one that I can't read the slope, but perhaps now you have the ability after yesterday to read the slope off this. Anyone know the slope off this? Can we figure it out? It's the same as just this one.
What?
What is the slope of this line?
3/2.
3/2? I think it's actually negative 2/3. So imagine the 2x is subtracted on that side, so it'll be minus 2x, and then divide by 3 both sides, so it'll be minus 2/3. But anyway, we're going to use the fact that we can get the x-intercept when y is equal to 0, and you get the y-intercept when x is equal to 0. So you'd split it up into two things you're going to find. Use that equation when y is equal to 0. So 2x plus 3 times 0 minus 6. So you had this yesterday. 3 times 0 is gone. So 2x minus 6 is equal to 0. Add 6 to both sides. You get 2x is equal to 6. X then would be 3. 2 times 3 is 6. So my point, I can graph the point 3 on x and 0 on y. That is an intercept found. Do the same process on the other side, but this time letting x equal to 0. You end up with 3y minus 6 equals 0. This, of course, would be 0. 2 times 0 is 0. Add 6 to both sides, you get 3y is equal to 6, and y ends up 2. I'll just write it up here. So my point is 0, 2. Make sure you have them in the right order. X comes first in the bracket, y comes second, always. Plot those 2 points. We did this yesterday. Join them together, and you have your line. Don't need to do it. Okay. So that was recap of Wednesday and Thursday. Looking back a little bit further, we created some formulas that we should be able to use. We had the, I think we created the distance formula first. We looked at the midpoint. And we had a formula specifically for gradient. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All these formulas use 2 points. This uses Pythagoras' theorem using the 2 points. So you take away the difference in the x, so you get the distance between the two x parts, the difference between two y parts, squared, square root to find the hypotenuse, which would be the distance. The midpoint formula, we'll just use mid for midpoint because gradient uses up m. x1 plus x2. So find the average of the x and the average of the y. So add them up and divide by 2, because it's 2 of them. And the gradient, which has a symbol of m, is find the rise, which is how far in y it goes up by taking away the y values, and x2, x1, over the run, which is how far it runs along. That distance, again, it's the same distance as we use here. All 3 of these use the fact that you have 2 points. Those 2 points, for example, use 2 minus 1 and 3, 4. You would label the first one, doesn't matter which one comes first, x1, y1. The second one, x2, y2. So that's an x point, that's a y, or x coordinate, that's a y coordinate. But the first one, that's the second one. So let's briefly just put these into the formulas. If you don't want to take a note on that, you don't have to. Yes, shoot.
What is there's like, the contact between the 2 equations?
Here?
No, not the midpoints.
Because this forms a point at the end, it's like this.
Oh.
That's why the comma is there. Okay, so let's briefly do the distance for these 2 points. So that would be the square root of the distance. x2 take away x1. So that's going to be 3 take away 2. I need to square that. And y2 take away y1. So that's 4 minus 1. Squared. 3 take away 2 is 1. That's 1 squared. So that's just 1. 4 plus 1 is 5. 5 squared is 25. And I need to find the square root of that to find the distance. I can leave that in the third form. That's okay. Square root of 26. Midpoint then, find the average. You could do this one in your head. I already know halfway between 2 and 3 is probably 2.5, but let's do it out using the formula. Midpoint, x1 plus x2, so that's 2 plus 3, divided by 2. y1 plus y2 divided by 2. And my answer should be a point here because it's midpoint. 2 plus 3 is 5. 5 divided by 2 is 2.5, or you can leave it as 5 over 2. Minus 1 plus 4 is 3. 3 divided by 2 is 1.5. Let's keep the decimals. 1.5 for that one. Or you can leave it as a fraction, that's fine. And the slope is this uphill, downhill? 2 minus 1, 3, 4. Looks like it might be uphill. Well, let's check out if we're correct. M is the symbol for slope, not midpoint. We'll work it out here. So y2, so that's 4, take away y1, that's minus 1 again. It's the same distance as here. And 3 take away 2 below. That's x2, take away x1. 4 plus 1 is 5. 3 take away 2 is 1. No negatives anywhere to make it negative. So my slope is just 5 over 1. Remember, the line is going uphill. The dude is facing it. That's a positive slope. You always read slope from left to right. And if it's going downhill, you're reading it from left to right. That's a negative slope. Negative gradient. Okay. Something else for slopes. Just going to get rid of the distance. Something else in a continuation of slopes. We need to deal with parallel and perpendicular lines, and therefore parallel and perpendicular slopes. Parallel lines, that would be something like that. Perpendicular lines meet at a T perfectly at right angles. But how does that affect two slopes? Hopefully we know this. Parallel lines have what? You know? No, parallel. Parallel lines, talk about the slope. Jack? Same slope. And that makes sense to me. If I draw a parallel line, or draw a line, and draw a line parallel to it, well, if the dude was climbing that one, and climbing that one, he would be faced pretty much with the same task. Because they're parallel. They would have, like, train tracks. Whereas, so if you want, you could say, oh no, do it for this one. Perpendicular lines then was a bit different. We had to, Feline, what was it again?
Flip it and make it negative.
Yeah, they use the reciprocal and make it negative. So they would have opposite gradients or opposite slopes. Remember, I'm interchanging slope and gradient constantly, but it means the same thing. They'd be exact opposites. Now, that's not a very technical mathematical term. But if you multiply the two slopes together, what answer would you get? Always?
What?
If I multiply two slopes and I know they're perpendicular, what answer should I get? Now, that's degrees. You get -1. Because, as being said, if one slope is 2 over 3, its buddy would be -3 over 2, the reciprocal. 2 times 3 gives 6, 3 times 2 gives 6, plus times minus gives minus. That'd be -6 over 6, or -1. So they would have the complete opposite gradients, opposite signs, and the reciprocal turned upside down. So this one is perpendicular to that one. Flip it upside down. some special lines based on gradient. A horizontal line, totally horizontal, has what gradient? It's gradient 0. Gradient equals 0. A vertical line is undefined. Why the difference? And we talked about this. It's all about the run. It's not okay to divide by 0, because that would suggest that 0 multiplied by whatever answer you got would work in reciprocal. Quick. If I have a rise of 2 and a run of nothing, and I said that that equaled a slope of 0, that's illegal. Why is it wrong?
It's undefined.
Because it is undefined. Why? But always remember that division is opposite to multiplication. It has to work in reverse. In other words, 2 would have to equal 0 times 0 for that to be true. And that's not true. So that's why we have to go with, there is no defined answer for that. When it's okay then to do the opposite way around, briefly look at that, 0 divided by 2. If we say that is 0, which we can do for horizontal here, there's a run of 2, but there's no rise. That suggests that 0 is equal to 2 times 0. And that is true. 2 times nothing is still nothing, so that one is true. That's why these are different. These lines also must have equations. Anyone give me an example? And we had one of these or two of these in the work this week. An example of a horizontal line with a gradient 0. Okay? Yeah. Y equals 1. Simple as that. Why? If you use your y is equal to slope x times or plus c, if the slope is 0, won't this all go to 0? It'd be 0 times x, which is just 0. So y will just be wherever it crosses the y-axis. So if you had an x, and I'll get rid of this stuff on the left. If you had an x-y axis, and you have a line that is perfectly horizontal, put in our scale. We'll use this in a second. There's a couple of ways you can think about this. This line will be called y equal to 2. You could write in y is equal to 0x plus 2. There's no slope, but 0 times x is nothing. That's why we just go to y is equal to 2. Why 2? Because that's its y-intercept. It's going through 2 here on y-axis. That's as much information as we need. Also, interesting, any point along that line will have a y value of 2. This one is minus 1, 2. This point here, 2, 2. The y value will always be 2. It is the only line that will always just have a y value of 2. That's why it's distinguished. Now, I suppose the follow-up question would be, how do we label a vertical line? It has no slope. It's undefined. If we go to try and substitute in, there's a couple of problems here. Y is equal to the slope times x plus c. The slope is undefined. So if I go y is equal to undefined times x plus, well what's the y-intercept here? What is it? not even, yeah, it's not even nothing, because you can't say 0, can you? Because 0 is a point. So, and it does not cross, you'd write maybe. That's not a very mathematical way of writing a line compared to this one, which is nice and clean. Y is equal to 2, done.
Sorry.
Yeah.
Squared X.
Yeah. This is my shorthand for undefined. I've called it so. You probably don't need to take that down because it is not the way we label the line. If this line is y equal to 2, what is the only distinguishing feature we know about this line besides its slope? Goes through the x-axis. At where? 1. So we know x is equal to 1 at that point. What's the x point? What's the point here? That'd be 1 minus 2. Point here would be 1 minus 1. Point up here where they cross over is 1 on x, 2 on y. It is enough to call this entire line then just x equal 1. Wherever a vertical line crosses the x-axis, because there's no defined slope and because there's no y-intercept, it has a special label, and it's x equal to instead of y. X is equal to 1. So an example, instead of writing this, is just x equal 1, and that's our example. So wherever across the x-axis, and if it's vertical, that will be its name. Okay, so we've shortened down. There was bits more. There was other practical applications of all those formulas with variables missing and things like that. But that's the basics. So what you guys need to do now, I'll put some of these on screen.